Chapter 3: Blood Vessels. So what are blood vessels? They are hollow tubes that carry blood through massive amount of blood vessels in order to distribute blood to body tissues. So you have two closed systems which begin and end in the heart: pulmonary and systemic. An average adult contains 5 to 6 quarts, which is 4.7 to 5% liters of blood, which is 7 to 8% of the total body weight. In one day, the blood travels a total of 19,000 km. Here are the major blood vessels: veins and arteries. Arteries go to capillaries. Vein, they go to venules. So both arteries and veins have layers of smooth muscle surrounding them. If all veins, capillaries of the human circulatory system were laid end to end, the total length would be 60,000 miles or 10,000 kilometers. That's nearly 2.5 times around the Earth. Arteries are elastic muscular tubes that carry the oxygenated blood away from the heart. Arteries are thick muscular wall structures. Why are they? Because to accommodate the high flow and pressures exerted by the force delivered by the heart. It depends on where it is located within the arterial system. Purpose is to prevent the arteries from collapsing and to enable the withstand high pressure of arterial blood. For an adult, all arteries carry oxygenated blood except the pulmonary artery. The larger artery is called the aorta. It is about 1 inch in diameter. More elastic tissue is contained within tunica media, but less smooth muscle. Blood is pumped into large arteries that branch into smaller and smaller arteries, which is called capillaries. Arteries direct the blood flow into the capillaries. In terms of anatomy, the arteries have 3 layers: tunica, adventitia, media, and intima. The hole inside, it is called the lumen. Tunica adventitia is the fibrous connective tissue. Within it, we have the nerves and lymphatic vessels. Blood is ejected into the aorta at a speed of about 30 to 40 cm per second, almost a mile an hour. Tunica media is the thickest layer of arterial wall in large arteries. It consists of smooth muscles and more elastic tissue. It is controlled by the sympathetic nervous system, meaning that it can be thick, it can be thin. It is based on the needs of the body. In smaller arteries, the elastic tissues in tunica media is replaced by the smooth muscles. Tunica intima. It has the inner lining of simple squamous epithelium called the endothelium. Arteries is for regulating blood flow from arteries to capillaries, regulating blood pressure through vasodilation and vasoconstriction, and carrying oxygenated blood through the body. So this is how a resin cast of the human artery system is made. So the embalmer would inject a clot bursting agent into the bloodstream. So the resin will be injected with the red dye together in the bloodstream, and the bodies will be dissolved in natrium hydroxide, which is a really strong alkaline, in a 120 degrees Celsius oven for 90 days. At the end, nothing is left except the resin. These are the arteries of a dog. So this organ, do you know what it is? Looking from the actual shape, if you turn it 90 degrees to the left, then you will know the answer. It is a testicle. So capillaries. The name capillary means hair-like. It consists of only a single layer of tunica intima of endothelial cells sitting on a thin basement membrane. So it is so thin that it enables the exchange of water, oxygen, CO2, nutrients, and waste products from the blood and surrounding tissues. So as you can see, this is the relationship between artery, capillary, and vein. So arteries would deliver the oxygenated blood into the capillaries, and after the capillary bed, you have the vein. So the nutrients will go out to the cells, and then the CO2 and waste will go into the capillary, and then the vein will deliver all of those back to the lungs. Capillaries are for exchanging, so they will exchange a lot of materials such as oxygen, CO2. What goes into the cell? Nutrients and O2. What goes out will be CO2 and metabolic waste. Veins, structurally they are similar to arteries, but the lumen is wider than the artery. So within the vein, you have similar structures such as the artery, tunica adventitia, tunica intima, tunica media. But the most important difference is that in tunica intima, or veins, they actually have these things called valves. Tunica media will be much more thinner and has smooth muscles. So valves, they function to prevent backflow of blood, and you can see here, in between both of these skeletal muscles, you have the vein. So this is actually the vein in your leg. So your veins will be sandwiched between your skeletal muscles. Why is it? So that this movement, contraction, will actually pump blood all the way back to your heart, because it needs a lot of energy to withstand or overcome gravity. So movement of blood through vessels. Arteries, they will be pumped by the heart. Veins, they will use the milking action of muscle to help move the blood. Venous return will be the volume of blood flowing back to the heart through systemic veins. So there are three ways: contraction of the heart, skeletal muscle pump, and also the respiratory pump. So this is the overall schematic. You have the systemic circulation from the heart, aorta, arteries, arterioles, capillaries, and back to the venules, veins, and vena cava to the heart. So veins and arteries, they function by delivering the stuff to the actual organs. Arteries and arterioles, if you want to compare with capillaries and veins, they will have much more thicker middle layer, which is called the mycelium. Endothelium. Sorry, not mycelium. Okay, so why is it quite thick? Is because it has a lot of smooth muscles, and then it has a lumen which is much more smaller. Capillaries is much more thinner, just one cell thick, but it has a big lumen. Compared to arteries and arterioles, it doesn't have any smooth muscles. For veins and venules, it has the biggest lumen. The smooth muscle will be less, and it also has valves. Okay, so arteries and arterioles, they function to carry oxygenated blood from the heart to tissues. Capillaries is for exchange. Veins and venules to carry deoxygenated blood from tissues to the heart. Arteries, they have thick walls with smooth elastic layers, but capillaries, they have very thin one cell thick layers. Veins, they actually have thin walls, mainly collagen, but it's not actually one cell thick. It is much more thicker than capillaries. About the lumen, arteries have the smallest. Capillaries have very small lumen. Veins actually has large lumens. Okay, now for the valves. Arteries have valves only in the heart, but others, they don't have any valves. Capillaries have no valves, but veins actually have valves to prevent any backflow. Arteries and arterioles would have blood at high pressure. Capillaries would have kind of low pressure, like for capillaries, but in veins you have blood at low pressure. Arteries would carry oxygenated blood except in pulmonary artery. Capillaries, it kind of depends, because entering the capillary bed you have oxygenated blood, but exiting it you have deoxygenated blood. And then what about with the veins? The veins, the blood are usually deoxygenated. So here's the cross section of artery and vein. You have outer layer, muscle layer, elastic layer only in arteries, valves only in veins, and both having an inner layer. So a good indication of efficiency of a person's circulatory system can be obtained by checking vital signs, which are arterial pulse, blood pressure, respiratory rate, and body temperature. The pulse is where the pressure wave of blood can be felt. So you monitor it at a pressure points where pulse is easily palpated. Measurements by health professionals are made on the pressure in large arteries. Systolic, which is the pressure when your heart is pumping. Diastolic is a pressure when ventricles relax. So as the distance increases from the heart, the pressure on the blood vessels would decrease. Okay, so this is how the pressure is measured. First of all, you have your brachial artery, which is the artery that runs lengthways to your arm. So with the rubber cuff, the doctor will inflate it to stop blood from flowing. At this point, there will be no sounds audible in the pulse because the brachial artery is closed. So as the rubber cuff is released, you will find out that there will be a really loud sound. So using a stethoscope, you can find the sound of the lap sound, which is the sound of the heart beating. So as the pressure around the arm cuff is released or is eased up, what happens is that the sound will actually go quieter and quieter until it's gone. So usually the pressure when the sound is gone will be around 70 millimeter Hg. So the actual instrument that is for calculating it is called the sphygmomanometer. So you have a column mercury indicating pressure of millimeter Hg when the blood is flowing. You can see when the cuff is inflated, there will be no sound because artery is closed. But as soon as it is released, you'll find that there will be a really loud lap sound. So I mean that artery is open. But when the artery is fully open, there will be no more sound. So at that point, you can find out that that is the pressure where the diastole happens. Vasodilatation. Vasodilatation means that how does a blood vessel dilate? Means that it will enlarge its lumen. So when the blood vessel is dilated, they will have much more transportation of O2, waste, CO2, nutrients, and also decrease blood pressure. So it is based on nerve stimulation, and smooth muscle relaxing, and then the cell wall will thin, enlarging the lumen. So when you have the larger lumen, the blood flow will kind of move in under a less resistance. Vasoconstriction would be the opposite. Nerve would stimulate to the vessel for contraction, and then thickness of vessel wall will be increased, and the lumen will be decreased. It will be smaller as a result. So at this point, the blood will flow under high resistance. What about vascular diseases? Vascular diseases are diseases on the blood vessel itself. Your blood vessel can undergo hardening, which is atherosclerosis. It can inflate, called aneurysm, and it can also be blocked, called thrombosis. For arteriosclerosis, it is the thickening, hardening, and loss of elasticity of the walls of arteries. This process gradually restricts the blood flow to one organ and tissues. As the plaque continues to build, the blood and oxygen supply will be decreased because the lumen is now much more smaller for the blood to flow. Most symptoms will not appear until blockage occurs. So when there's a total blockage, then the organs affected might be having problems working. Aneurysm. It is a localized blood-filled balloon-like bulge in the wall of blood vessel. So it is all due to the wall of the blood vessel being so weak that with higher pressure, it will just bulge into a balloon. So when it bulges into a balloon, there will be some risk of it being erupting, or they will explode, or they'll rupture. When they rupture, a lot of the blood will be leaking out into your tissues, especially your brain, especially your other organs, causing low blood pressure and low blood volume, and lastly death. So risk factors include diabetes, obesity, hypertension, tobacco use, alcoholism, high cholesterol, copper deficiency, increasing age, and tertiary syphilis infection. Thrombosis. Thrombosis will be the blocking of your blood vessel with a clot. So usually you want the blood clot to form on a plug, or to form on a wound. Okay, you want to close the wound. But in this case, they are just freely running, and then they were just floating around, and then due to its nature, it will just become bigger and bigger. It will clot. Okay, when the thrombus is large enough to reduce blood flow of tissue, you will have hypoxia. Hypoxia is oxygen deprivation, which occurs, and it will actually cause the organ to be devoid of oxygen. So what will happen is that your organs will be forced to function without oxygen, which is anaerobically. You really don't want that to happen. So if that happens, you have a lot of waste products, a lot of lactic acid. Okay, so this happens during stroke. A larger thrombus can really cut off the whole organs from oxygen. We call it anoxia. So without any oxygen at all, your organ can just fail. Okay, you have tissue death, you have infarction. Okay, so what happens? What actually causes thrombosis? Usually, it's caused by the abnormality of composition in blood, and quality of vessel wall, and the nature of blood flow. Here, as you can see, all of these are thrombosis. All of these are thrombus that has been removed from the blood vessels. Note how they look very, very twisted. So all of these twisting and turning are actually based on the flow of the blood around it within the vessels. So it actually causes the blood vessel to be mangled, to be twisted. Lymphatic system, it is the complement of your blood vessel. So you still remember plasma. Plasma is what you call the colorless fluid that is within your blood. So during the movement of blood through capillary, the water or the fluid will leak out. So this water, or what's called it, the fluid that is which is plasma, which leaks out, they will actually stay in your tissue fluids. So what happens that your body is actually leaking out all of this liquid to the outside. Okay, so if this happens and this liquid is not replaced, then you'll have lack of water, you have lack of fluid, and the organs that is related will be inflated, you'll be bulging. So we need the lymphatic system to collect all of this extra water that is leaking from your blood vessels back into the system. So lymph, it is excess tissue fluid which cannot be returned to capillaries by osmosis, but it is drained into lymph capillaries. Because lymph capillaries are colorless vessels which are present tissues, and it will join up to form large lymph vessels. The lymph vessels carry lymph to the capillary nerves, which will empty into a heart to the superior vena cava. So as you can see, the vena cava is near the middle left. So the lymphatic vessel will carry this fluid all the way back to the vena cava, so that the blood is whole again. You have cells, now you have tissues. Okay, lymphatic vessels contain valves which help to keep the lymph flowing in the right direction, and contractions of your skeletal muscles also aids the flow of the lymph. In between, you have the lymph nodes. Lymph nodes are situated on the way from tissue to the subclavian veins. As you can see, the lymph nodes, they look like a bean. They have capsules, sinus, nodule, and cortex, and in the middle you have the hilum. So as you can see, those nodules are what's called the lymph nodes. They are situated in between some of the parts of the lymph vessels. So you travel for a while, and then you have a node, and then travel for a while, you have a node. So along the way from the tissues all the way into the vena cava, you have a lot of lymph nodes. So lymph nodes has many tiny spaces like a sponge, and lymph is filtered through the spaces before it can continue to return to the bloodstream. So it contains large numbers of white blood cells to destroy bacteria and toxin in the limb. So in tissues, we have also lymphoid organs. So tonsils and adenoids, both of these will respond to inhaled pathogens, meaning that in these lymphoid organs, it has a similar function. Inside, they have a lot of white blood cells. Whenever there is invasions, they will inflate. They will actually kind of bulge because a lot of white blood cells within it will multiply. So whenever you are having a fever, you can actually feel it kind of bulging in your throat. And also when doctor says okay, he is actually looking at your adenoids. If the adenoids are large, meaning that you are actually fighting an infection. Spleen. The spleen filters pathogens and worn out blood cells from the blood. Thymus glands, they will mature the T lymphocytes essential to the immune system. So combined with the other two, all of these are the lymphoid organs and tissues. Functions of the lymphatic system: it is to return the excess tissue fluid to the blood system, and it is also a medium for material exchange between capillaries and tissue cells. Without it, you will actually losing a lot of liquid, and a lot of this liquid will collect in your intercellular space, causing your arms to be bloated, your legs to be bloated, and you might need to get even more water to build up the blood again. Okay, so what is this thing? This thing is called a lacteal. And so lacteal, they are the place where fats are dumped in. If you can see there in the picture, that's a small intestine's vilus. So vilus is actually one of the fingers. Within it you have blood capillaries, to and from. So you have a capillary, and in the middle you have lacteal. So lacteal will be carrying fats all the way to the lymphatic system, and lymph node would filter the lymph. So lymph node will also create lymphocytes, which make the antibodies. So as a conclusion, arteries transport blood from the heart, veins carry blood back to the heart, capillaries is for exchange, and blood vessels have 3 tunics except capillaries. The end.